So, how did you find the Python materials?
Quite interesting.
It's not hard, is it?
It is, yes.
Is it hard? I've tried to make it like as easy as I can. Uh, just to make sure, did I upload the materials? I think I did. Yes. Okay, cool.
Hi, Mohammed.
Well, hi.
So we are starting data science today.
Yes.
So the Python, is that all just one lesson for last week? I
Well,
mean,
Python,
is that
Python. Well, you will still keep doing Python, okay, through the labs and stuff. It just when I delivered the Python materials, that's the materials to give you the basics about
okay?
the Python programming language, how to do variables, what are the if statements, while loops, and the data types that are available in there.
Okay.
You need if you don't have background in programming, that's the basic that you need to know about Python and how to use
Okay.
these things.
All
Okay,
right. Thank you.
no problem. So, data science. Um, well, motivation for the course, as saying here, data is driven everywhere. We are surrounded by data. And that's what I always say when it comes to data science, comes to um, uh, machine learning or any other stuff we have nowadays in the modern technologies and big data. Um, we are surrounded by data. Everything we have is data. And on our phone, our daily life, we use uh, our laptops, TVs, anything we do. When you browse online, all these things are data. Okay, so modern data acquisition is inexpensive, like smartphones, embedded systems, and inexpensive sensors, medical device simulators, and so on. Okay, so the data is everywhere. It's being collected uh, constantly through your smartphones, IoT sensors, the home assistant like Google Home, for example, and contributed through Facebook, Twitter, Instagram, LinkedIn, all these platforms as well. So storage is cheap and compute power readily available and repeatedly increasing. Computer cluster are available to enable parallelism and special architecture developments for machine learning operations. So all these available are not just for those who can afford to own them, but through the commodity of the cloud as well. Okay, especially when it comes to computer cluster, we do have one at PCU, which we recently installed. Now we have 3 clusters, I believe. We installed the last one just recently there. Well, it's my area of research as well. The high performance computing. It's now a very hot topic in the research area as well. So if you're interested, you can just read about it. It's very decent, like topic to read about. Um, also, you will see as well. Like I think Facebook recently they installed one of the biggest high performance computers in the world. Well, for AI particularly. So yeah, so this increased the ability to collect, store, and process data has led to uh, a revolution in how we do things in almost every field, from biological science to social science, humanities, political science, policy, marketing, and so on. But just because we have data doesn't imply we understand it. It must be processed to drive information, make models, enable predictions, and make this diagnosis. Uh, we want to use the data to develop or um, argument models using machine learning and other algorithms. So the key questions in data science are like how do we explain and predict the world? Okay, the desire to make sense of the world is not new. In several domains like physics, for example, we well-defined models have been developed which have for years been used to make predictions. The novelty of data science is the ability to create or refine models in domains where the underlying principles may not be understood. Okay, so for example, how do you make prediction? We don't like human behaviors, biological brains, whether product will be a success, what to invest in. Okay, um, all these things are the key questions when it comes to data science. These are the key questions you will need to basically understand, if I'd say, or basically that's what you need to ask. So the outlines of this topic is what is data science, considerations around big data, what does analytics involve, disclaimer and recap, checkpoint exercise, practice notebooks. Word cloud of data science. If you do word cloud in data science, you would get something like this. Machine learning is, of course, very important as our statistical techniques languages like Python or R language, which I don't like. Tools like Hadoop, Kafka. You can see all of them here. So those are the ones I'm saying. Like you have machine learning, Python, R, Hadoop. Yeah, lots of things. Like Hadoop, Kafka, database like SQL or MongoDB. Visualization like using Tableau or D3, etc. Okay. The idea that machine learning is part of much bigger ecosystem and must used at scale. All right. Also, when it comes like once you will, if you ever come across a like data mining or text mining from Twitter or something, algorithms like that. One of them you can make basically a word cloud like this on what is the most trending word at the moment. So I think I've done something like this before to the most trending words on Twitter, which was I think data mining, I believe so. And also the connection shows you the connection between the words and stuff. Oh, it was quite interesting. All right, moving on. So, data science interdisciplinary. missing in this word cloud. Um, However, it's inherently interdisciplinary. Data sciences. It requires domain experts to understand what or where the data is and what questions are important to ask. So mathematicians and statisticians to understand modeling and interface computers scientists to build systems and design algorithms and methods for analysis. Visualization experts and storytellers to effectively communicate results, and policy and legal experts to understand the borders, social context like ethical implication um, of the field of a field that has such a dramatic effect on every aspect of our lives, like getting a job evaluation, what ads are served up, and so on. So data science takes ideas from computer science, math, statistics, and apply them to problems in science, economics, social, businesses, law, or more. Okay, so this sign in here, okay, you see this one, like the upside down U. Um, that's when it's applying them. So it takes computer science, statistics, math, and then applies them in science, economics, sociology, businesses, law, and so on. Okay.
Mohammed, a small question.
Yes.
How much coding knowledge do you need for to be part of the data science as a profession?
Well, with the, I mean, when it comes to working on the cloud, you need to know how to use all the services, like most of the services in there, right?
Okay.
And as we've done in the AI part of this course,
Okay.
is it's easier to apply all these machine learning stuff because the code is already there. Okay, so your work would be how to pre-process the how to pre-process your what's called uh, data, how to prepare your data to be used for um, all these things. Okay, so
Okay.
that would be the main job you need to do, and of course you will still need to learn about coding because sometimes not everything will be available. What if you want to do, for example, your own algorithm? So that means you have to do coding, and if you looked into Colab, it's a very good tool to use. So you can basically um, use it to create your own or practice Python or other languages. And to be honest, Python is very easy to understand,
Sure.
much easier than any other programming languages.
Okay. Thank you. Thank you.
No problem. But so what's tricky about data science takes ideas from computer science, stats, math, and then apply them in science, economics, so on. But of course, understanding the domain will require an expert, which outside the scope of this course. Okay, so this course will initially focus on the technical and data manipulations aspects of data science, which we'll call data analytics. Some people also call it data engineering. Okay, so data science is much broader and includes domain experts communicating the results to use via storytelling, visualization, policymaking, and so on. All right. So data analytics. Our focus here is to managing and creating models from data at scale, complex, heterogeneous, large, high dimensionality, velocity. We will touch on many related techniques and issues: machine learning, distributed computing, distributed algorithms, and parallel computing. We will leverage standard tools and platforms and points to others. Okay, so our focus is on the foundations of machine learning cloud platforms. You should continue to study in depth afterward. All right, so this is a typical workflow for the data analysis. So raw data is obtained and must be clean and regularized. Okay, we may also want to complement is using other data which also must be cleaned and regularized. Okay, so that's the part when I'm telling about the data cleaning or pre-processing. These are steps of pre-process the data, clean the data, knowing what rows, what columns you need from that data. So for example, if you have it, let's say a CSV file, which contains 20 columns, but you don't actually, you could not actually, in some cases, you don't need the 20 columns, all of them, okay? So you may need to clean the data using some coding, if so, or some tools available on Azure, for example. Um, so you could easily just select what data you need in there. For example, if you do something that's not related to the, well, let's say the names, you have column called names, first name for middle name for surname. You don't need these columns. They're not going to be affecting the results of your algorithms when you apply them, right? So in this case, you need to clean your data, narrow the amount of columns you have, for example, so that will help you that will help to make the the algorithm perform well. Okay, so that's the first thing you need to do: clean your data. That's the first thing ever you need to do. In some cases as well, you might find some cells or rows they don't have data, so you need to replace the empty cells in your database or the Excel or CSV file. All right, so the data, which may come from different organization and be different format, then must be then integrated and put in a format it which features can be extracted to help make prediction. We'll talk about the first two steps next. Okay. Uh, Consideration around big data, structure, cleaning, and linking. So sampling is, well, open and close words, observation vs the universe. Okay. Sampling is one of the most important factors in determining the accuracy of your results. Is a well-studied area that requires collaboration between the domain scientists and statisticians. In data science, however, data might be collected for one purpose and reused for another purpose. So there are additional issues of how representative the data is for the given research question. In a later model, we will briefly consider this issue. For now, we will assume that the data has been collected, and we will consider what must be done to put it in a form in which analysis can be performed. So let's take the popular example of cats. Okay, everyone loves information you can find about cats on the internet. For example, there is an image of genomic information article about cats, free text, and semi-structured information. We want to be able to bring all together, um, ringlet, and bring it into a form that cats, for example, be used to develop a model for recognize various type of cats. Okay, so we have the image, we have the genes, the text, we have the data plus features extraction, wrangling. Okay, like how you see here, English labels, the cat, gato, whatever, description, and so on, and then we extract all this information from there. Let me send you this link as well. Interesting. Uh, okay. So this is very, uh, very useful thing. It shows you different techniques that's used in data science. All right, moving on. All right, so the goal is to take raw data into structured data over which analysis can be performed to create knowledge. Okay. Um, so the raw data, structured data, has fields, entities, objects, machine learning features, and may be very irregular or semi-structured. Is everything clear so far? I know that's could be lots of information. Just that data science is quite a big topic, to be honest, and that's the main thing I think for the jobs that you will be looking for. You need to understand these things, which will help you a lot later. Okay. All right. So linked data find patterns in connectivity, clusters, path, and so on. This is very well. I find it very important, like interesting topic because it touches our lives. So something we see, what we can find in our lives, basically. So I believe that hopefully you will You will know what are the um. Let's I just want to send you a link as well regarding this one. I don't know why are the links not what links are not working. Anyway, we've been talking about a lot about entities. All right. So by entities, I mean tables, which has rows and columns. Okay. Uh, so we've been talking a lot about entities, real world objects, and features for entities, but sometimes it is the relationship between entities that's the important one. Okay. A friend relationship in Facebook, we commonly represent relationship between entities as a graph, with node being the entity and the edge being the relationship. Okay, so these are nodes in here. All these red dots, you see them, those are nodes, and all these lines represent there is a relation between this and this and this. There is a relation between this one and this one, and so on. Okay, so we can then use those relationships to make recommendations. For example, who you might who you might become who might friend or might befriend, or what type of music you might like to listen to. In doing so, you might look at properties for entity, as well as the path between the entities or connected components of it. So there's a lot of algorithms that we might want to run over these graphical models. So this applies well beyond social networks to areas such as genomics. Okay, one I think most of you use Facebook or used Facebook before. So if you are a friend with your friend and but you're not friend with another one, for example. So let's say you are a friend with X or Y or Z, and your friend has other friends, but you're not connected to them. Okay, so sometimes we're using these network to suggest to you people you might know, okay, through your friends and so on. And you see that there is a common people between you two sometimes. So yeah, that's one of the things you might uh, find. Um, I'm just trying to find you something. So when it comes to some kind of um, you see something like this, but in much bigger way, basically. So you have this person. Let's say he has 200 friends, okay, and basically there is a direct link between them because they are friends linked to them. There is a relation between them, okay, and this one related to this one, and so on. So you see the graph. This is just small graph, by the way. When it becomes bigger, it becomes more complicated. Uh, you could see something like this. It's very hard to visualize, or something like this. See the relations, and then you would do like you will use well, clustering techniques on machine learning clustering to see each one of those, to cluster them basically. Okay, you see something like this. Me personally, I did find something bigger than this one. Yeah, I've done something similar to this one. It's fun. All right, so there is another type of graphical structure that's important called knowledge graph. Okay, so this is a centerpiece of what Google use to aid search. So it captures the concepts of a domain and the relationships between those concepts. So, for example, not shown in this image, um, um, we might have Barack Obama or Donald Trump at the levels of knowledge graph. Okay, so um, and we know that there are certain things that those two people have in common. For example, being president. So being president is a concept. What we have called, what we have, what we could have um, in the knowledge graph. So with Obama and Trump both being instances, uh, we could also talk about some of their dissimilarities. So being different political parties, for example, um, you can use the knowledge graph to disambiguate and impose structure over the entity. So, for example, a knowledge graph is can and is being used to improve search. So, suppose we are searching for Michael Jordan, and there are several different people's named Michael Jordan's basketball player, actor, machine learning researcher, and so on. So, how does the system know which one we are talking about? So there's lots of information about what your browser has been collecting. It could look at your search history and decide which one most likely you're interested in, like Michael Jordan, the machine learning researcher. Okay, uh, these are one of the things uh, that sometimes make you scary. Um, Also, there is a link that might be useful for you. That is associated with data modeling. Uh, 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 some parts of that one. So it's introduced you to the RDF, relational data resource description framework. Sorry. Yeah. So moving on, a third type of data we have that we will be talking about during this session is temporal data, which is called time series or streaming data. Here, we are not primarily interested in entities or relationship between entities, but how the data change over time. In this image, we can use the temperature data, sorry, the temperature data as it changed across the globe, which could be important if we study climate change. For example, we might worry about how the temperature in the ocean is raising and what are the efforts over the ecosystem. I think I've showed you an example before on a temperature prediction model that's being created. Uh, before. I'm just trying to find that model to show you. Okay, so this is one of the examples. So I had a data set that have data since the 1880 till 21, basically. So quite not very large. It's all right. I mean, like it's not really huge data. Anyway, so it has the average temperature in every month. You see some of them are missing, so we had to replace these with zeros, or basically depends on that temperature in that month. It predicts what the value should be in there, and so on. So moving from there, we had to count the count. The count should be all the same, obviously. The mean value, the minimum, maximum, and also we've worked on, yeah, so we've plotted the temperature, how the anomaly in Celsius, temperature anomaly in Celsius. We see here that in 1880 where it was, and in 21 there is quite a huge increase in the temperature over time, and the same here without the noise that's happening here, right? So it shows you only one line, which become easier to read. And again, so we predict before that, almost before that, not really, until 2016. Moving on, we'll see how the temperature will be. So somehow we are here in the middle now. Okay, we are here in the middle, but also it shows you from that time for the 21, how the temperature will be, and yearly how from January to January how it will be then. Okay, so all these predictions, as we are here now, and it predicts that it will keep increasing, which will be affecting climate change. And using these kind of things will help us to understand, to have a quick, to do quick action. So we will be able to prevent that increase in the temperature affecting the climate. Okay, so finally, we should talk about the tabular data. For example, city governments are collecting a lot of data and making it publicly available. For example, parking tickets and accident data. Well, frequently questions you want to ask involve linking these data to other data. For example, here we have taxi cab data with information about trips that people have taken. So taxi picked up a person and drove them for 50.1 miles, for example, here. It also shows the latitude, longitude. You can refer, you can infer certain things from this, such as the average length of trip or the most frequent pickup location based on the longitude, longitude or latitude. However, you can learn even more if you combine it with each other, with other information. So, for example, geocoder will take latitude, longitude, and give street address information, which might be more meaningful to you. Okay, so it will take these latitude, longitude, and you can put them there to give you some information about that one, which will be much better than presented as latitude and latitude. As we can see here, so for example, it gives you exactly where the pickup address. So what makes data big data? Do you think that it's a gigabyte, petabyte, yottabyte, million records, billion records, trillion records? What do you think it is? Well, in data science, the focus is on big data. So what is really makes the data big? Of course, the size of that data matters. It may be too big for an Excel spreadsheet or too big for the main memory in your computer. But it is also heterogeneity of data. For example, data being combined from images, free text, and structured sources. And the fact that the data may also be repeatedly changing or streaming, requiring different types of processing. So even if we focus on the on just on the size of the data, there is an issue that may be addressed. Observe that the size is affected by both the number of rows or observations, as well as the number of columns, or what you call it, features. So when the number of rows is very big, you cannot just use a brute force or naive algorithm. So you have to worry about the efficiency. It may also require you to use parallelism to speed up the computation. So when the number of columns is big, you may have to reduce the number of features using feature selection and dimensionality reduction. These ideas will be focused in details later, but feature selection is the process where you automatically or manually select those features which contribute most of your prediction variables or output in which you are interested. Prediction, a variable, or the dimensionality reduction is the process of reducing the number of random variables under consideration by obtaining a set of principal variables. As I mentioned to you earlier, sometimes in your data, you don't need all the columns in there, or what we call them features. You don't need all of them, so that will affect the performance of your algorithm. So it would be better. You should, when you start do pre-processing, to look into these things, clean your data, delete the unnecessary columns, and so on. So when it comes to data analytics, what does data analytics involve? Or what does it include? So the goal of data analytics is from data to knowledge or action. Okay. Once you have something in a form that can be read, the next step is to understand the data and look for the patterns. You may do this by hand or use visualization tools to get an idea of what the data is about. So once you understand more about the data set, you make a hypothesis to test the hypothesis. You may need to obtain additional data, find, collect more data, run experiments that generates more data about the truth of the hypothesis. Finally, you use the statistics and test if the hypothesis is valid. So the typical pipeline is that at the bottom of this page, at the bottom of the page. So sometimes the apply steps is linked back to the it's linked back to the collection step, and ends the extrapolate step. Machine learning is the recognize and build steps. Okay. Some of the activities in analytics and some of the activities involved in analytics are listed here. I noted with the steps in the pipeline in which they appear. Okay. And a very important part of the analytics are the ethical issues, which must be considered at each step along the way in this pipeline. So the last issue is what question should be asking, what applications make sense. So it's easy to get data, but it's hard to do something useful with it, right? One of the first data science problem posed to the community at large from about a decade ago was called the Netflix prize. So Netflix wants to improve the video recommendation for their customers. Netflix shared anonymized data with the public and asked for solutions with a $1 million price. At this point, users would rate a movie from 1 to 5 stars. So there was a lot of available data, structured information about the movies, titles, actors, other people's rating, text descriptions, and so on. So each person working on the challenge expected different features, extracted different features. So use them in various ways to make predictions using techniques from the natural language processing, or NLP, machine learning, and related techniques called collaborative filtering. But Netflix challenge ultimately revealed another issue, that we always need to consider the data science space. So it turned out that clever researchers were able to correlate the anonymous Netflix viewership information with reviews posted with IDs to the Internet Movie database. and reverse engineers who many of the viewers were. Okay, so in many ways, the Netflix challenge is a micro microcosm of the kinds of issues encounters in data science. Techniques are extracted the right features. Techniques of machine learning, computing is a very large scale, and being very um, I'd say um, aware about of the data privacy and other ethical issues. Okay. I think also NASA last year as well. Well, I participate in that one. It's called NASA Space App Challenge 2021. So last year, I was working in this one. In Birmingham, we had a center here in Birmingham as well. So yeah, so NASA, what usually NASA do is it will list lots of challenges, okay, and let people basically work on them. So the prize was last year is to take you to watch the space rocket launch. It was quite a good one. We had 3 people from Birmingham was nominated to go there, and I think these guys from Morocco are the one who won the challenge. So they worked on algorithms basically to track the space trash.
Mohammed, I can't hear you.
Hello, guys. Can you hear me now?
Yeah,
Yes.
that's better.
Okay. So yeah, I was talking about the Moroccan team who won the NASA Space App last year. Thing. Yeah, so they came up with an algorithms to track the space trash. It was really one of the good projects that's been done. Or like only last year I knew about the NASA Space App Challenge, but apparently it's been happening every year. So I think there will be another one this year as well. We had one in Birmingham. There were one in London. So yeah, that's Birmingham. So yeah, we had one in Birmingham here. We had 8 teams. That was the one of the teams that we working with. That was my team. Yeah, it was really good experience. We had one winner, which is good. Anyway, moving on. And another example, genomics or computational biology was an early example of data science. It was putting a man on the moon grand challenge of the 1990. So over decades, innovations in technologies to collect genomic information have provided a tremendous amount of data and algorithms. And techniques have been happening in many different fields across humanities, political science, economics, so on. So high throughput genes sequencing allows us to capture a vast amount of DNAs and use it to do interesting things like the type of analysis that's being performed by companies such as 23 random 23andMe, I think. Yeah, 23andMe. The information is also enables other things such as personalized medicines, for example, developing treatment plans for individuals rather than generic treatment plans. Okay, an example of the pipeline for this is showing on the right, which perform the regulating discussed earlier, align with other data banks and make predictions. So data science requires human insights, in particular by the domain scientist. It's not just turning the crank using statistics and machine learning. Okay. Here's things that you should consider when embarking on data science projects. What questions are you answering? Okay. What are the right scope for the project? What data will you use, and what techniques are you going to try? How will you evaluate the results? What maintenance will be required? Okay. Disclaimer and recap. A word from practitioners in data science. At least 90 to 80% of their work involve not machine learning, but working with experts to understand the domain, assumption, questions, and so on. Try and catalog and make sense of data sources, wrangling, extracting, and integrating the data, cleaning, and wrangle data. So recap, what data science involve. Data is high dimensional, hard to understand, and requires an understanding of computational and I/O cost, input output costs. Given an integrated data set, often the hard part, data science involve extracting and selecting features as well as adding semantic structure to the data. There are many applications of data science, from discovery to try classifying to classification, to recommendation. Sometimes statistical, sometimes algorithmic, and sometimes reliant on extraction. So that was the slides for today. I know there are so many information there, and so many could be so many new things as well for you. So what do you think about what we talked about? Any questions? No questions? Okay then. So I have a quiz for you. Actually, for the quiz. So I have this for you to go through. Okay. So you see here, so standard aspects with Python. If you want to print something, you want print in brackets and the quotations. 5 plus dot 5, like 0.5, for example, gives you direct answer. And the same thing for math equations or like calculations. X equal, we have a list in here, and then print car area, then and then X. So it prints it to you like car areas, XE, F4, S space, XG, F type, and so on. Prices. We have list of prices or an array. You have to print prices are, and then for the index or the I in range, the length of the prices. So prices I, your index, equal to integer divided by 1.2. So print out what the new prices. So prices without the VAT. Okay, and we print it out in here. And the same thing for the other one. We have course prices, or it's already prices defined in here. So we have cars, empty dictionary, I believe. I think so. So for index range of length of prices, Okay, I need the car X, which is this one. Okay, car X index equal to the price, print car. So it will print to you the cars and their prices in there. So in here, we have a dictionary called cars. Let's cut price by 5%. So this is just to cut to show you. We have an important thing when it comes to Python is the libraries that we use. So there are different libraries that you can use in Python. If you want to import a database or a data set, you need to import a library which will allow you to do that. Okay. In some cases, if you not, it will give you an error. So pandas as a PD. So import pandas. Okay, here as a PD. So it presents as a PD here. This library will allow you to import the data set in here. And also, important thing, when you upload your data set, it as soon once you close it and upload and open the page again, it will be removed, so it won't be stored there. Okay, see now there's no error because the data is there. I just added. I'll send you this file. What you need to do is to go to Colab. If you didn't sign in for Colab, please do. It's the same as Google account. If you have it, then it's okay. What you need to do, you need to click on upload and then either drag and drop a file or just choose the file that I will be sending you. Okay. Do you have any questions?
If anybody already have a Python install, do we still need to have the collab?
Well, Colab, it will be a better practice for you because all your code will be stored there as well. Sometimes there are some libraries that's already imported in there. So if you're using Python on your own machine, what is the what's called? What is the software you're using?
The version I'm using?
So if you want to use
Right.
Python, right?
Yeah, Python 3.10, and I'm using that with the help of the VS Code.
So Visual Studio you have.
Yes. Yes.
Okay. You still can use Visual Studio. It doesn't matter. It's absolutely up to you what software you want to use. But this one, it will be easier if you have an error, for example, you can just literally click share and share it with me, and we'll look into the error together to find the solution.
All right, all right. There's another question, and it is very, very basic question. I'm sorry. I please tell in the simplest word that's what is this means why the IDE is important when you can work in the Python itself. Why you need to install like PyCharm or VS Code for that. And another question is that the Jupyter notebook is a dictionary or what it is.
Okay, there's different types of lists or dictionaries, tuples. So each one of them presented in a different bracket. So we have square brackets, curly brackets, and the curly brackets that we have like those. Okay, so these present the tuples, this present the lists, and the curly brackets present the dictionaries. Okay, each one of them we talked about last time. They have their own features. They can be changed. For example, some of them cannot be changed. Some of them can. Okay. So each one of
Yeah.
them has different features, which
Uh,
we, yeah.
I'm sorry, my question is, I think I didn't ask properly. When you have a Jupyter notebook, and
Yes.
then you have to install the Jupyter notebook, and then you install the Panda or something else, whatever you need. So
Any software you're using, you need to
yeah,
install the libraries.
library.
And
So the Jupyter notebook is also a library, and the Pandas and other things are also libraries.
no, Jupyter is well, how can I explain? It's like the collab, but it's the offline version.
Okay,
So
okay, okay.
you
It's
can
not a
go there,
library.
for example. For example, if I create a new one, so usually what I do, I create a new notebook in here, which is this is like a notebook. So I can write my code in here and then add a text to explain it, add some explanation in here, whatever it is. Okay. Some
Yeah.
titles and so on. So this would appear like this at the end when I export it as a PDF. So if I export it as a PDF or so on, okay, it will become like clean to me, like the ones that I have for you on GitHub.
Mm-hmm.
Uh, so, so let's say in here, okay, when I extract the page, I have this is one of them. So this is I've showed you this before, and this is the other one. So I have I can add text within the code and stuff. That's why we're using Collab and so on. You cannot do the same thing with the, I'd say, with the with the Visual Studio. Visual Studio
Mm-hmm.
will only extract the code for you. It gives you
Mm-hmm.
results. Okay. But if you want
Yeah.
to present your code and submit it like this, for example, and so on, you need to use something like Jupyter or Collab, which will give you the flexibility to explain and to make a whole reports, including the codes inside the report and so on.
Okay. Okay. Thank you, sir.
No worries.
Hello.
Hello.
Yeah. Okay. I'm trying to upload the file you sent to the chat, but I think the collab is it comes with some sample data, right?
Yes, it needs the data, correct.
Yeah.
So that would be the data here. And I just shared the data with you.
Okay. So, so how do I create a file on the collab? Is it like a GitHub that I can save my files there? But I'm seeing a message that the file disappear after the runtime. I don't understand.